In this video, we're looking at the area bounded by cosine x plus sine x on the interval 0 to pi in two different ways. And in part A, we're interpreting the area as the signed area bounded by the curve, and that means the area counts as negative when it's below the x-axis. In part B, we're looking at it as geometric area, which means every contribution of area counts as positive, and that means we need to make some modifications so that area beneath the x-axis counts as positive. So in the interpretation of part A, the signed area, that's just the definite integral on the interval that we were given. So I have the integral from 0 to pi of cosine x plus sine x dx, and I simply guess the antiderivatives of each of those terms in the integrand. And the next thing to do is to evaluate across the limits of integration, so I plug in the pi for the upper limit, and I've got a sine pi minus cosine pi, and immediately I see the first term vanishes. The sine of pi is 0. And in my lower limit, I have a sine 0 minus cosine 0, and again, the sine term vanishes. Now I just replace cosine pi with negative 1, and I have a negative 1 in my first term, which is a positive 1. And then I replace the cosine of 0 with 1, and I end up with a negative 1 inside this parentheses, so that's another negative 1. So this reduces to 1 plus 1, and I get a signed area of 2. In part B, the problem is more difficult because I need to split the integration interval at that point where the function dives below the x-axis. And basically, we just tack a minus sign onto the definite integral of the second piece that's below the x-axis in order to make it positive. So the first order of business is to find out where the curve is equal to 0. So we have to figure out where is cosine x plus sine x equal to 0. And you may just guess a solution at this point by visualizing angles on the unit circle between 0 and pi. It may make it a little bit easier if we divide by the cosine function. And sine over cosine is tangent. So I have 1 plus tangent x equals 0, or the tangent of x is negative 1. And again, we're looking on the interval 0 to pi. So I'm thinking about the upper half of the unit circle. What angle gives me a tangent function of negative 1? In other words, what angle has the same magnitude for the sine and cosine, but differing signs? And that angle is 3 pi over 4. Remember that the cosine of 3 pi over 4 is negative root 2 over 2, and the sine of 3 pi over 4 is positive root 2 over 2. And this means the sine divided by the cosine is going to give me that negative 1. So now I need to set up the area as two separate integrals, one for each subinterval. So there's two integrals, one for each subinterval, and what we're doing here is just multiplying the second one by negative 1, because we can see from the picture that's all negative signed area. So that second integral is going to give me just the negative of the geometric area of that piece. If I multiply by negative 1, I've corrected the problem, and I'm going to have geometric area. So the antiderivative is the same for each of these pieces, and it's the same as in part A. And now it's a matter of subbing in all these upper and lower limits. Notice when I sub in the upper limit on the second term, I have that minus sign out in front. When I subtract the lower limit, I get a plus sign. And I notice that the sine of 0 vanishes, the sine of pi vanishes. And then if I look at the cosine of 0, that's 1. So in this second term, I have a negative 1, in other words, a positive 1. And then in the third term, the cosine of pi is negative 1, which gives me a positive 1 inside the parentheses, but there's a minus sign out in front. So I get a negative 1 from that. So the sum total of those middle two terms is a 1 minus 1, and the whole thing vanishes. What I'm left with is two terms with a sine of 3 pi over 4, and then two terms negative with a cosine of 3 pi over 4. So I get 2 sine 3 pi over 4 minus 2 cosine 3 pi over 4. And now I can plug in the sine and cosine of 3 pi over 4. The sine is root 2 over 2. When I multiply that by 2, I just get square root of 2. And then the cosine is a negative root 2 over 2. When I multiply that by 2, I get a negative root 2. So I have root 2 minus negative root 2. So change those to pluses, and I have 2 square root 2 for my geometric area. And that's it. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.